Hello guys, today we learn how to write Fibonacci series in C using recursion. To implement this, we have required Visual Studio Code, MinGW compiler, and C++ extension installed in Visual Studio Code. Now let us see what is Fibonacci series. Fibonacci series is a sequence where the next element is the sum of the previous two elements. The first two elements of the Fibonacci sequence are 0 followed by 1. So here you can see Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21 and 34. Here you can see first element is 0 and second element is 1. How can we get next element? Adding up previous two elements means 0 plus 1 equal to 1. Same if you want to next element, then what we need sum of previous two element 1 plus 1 equal to 2 and 1 plus 2 equal to 3 and 2 plus 3 equal to 5 and 5 plus 3 plus 5 equal to 8 and 5 plus 8 equal to 13 and 13 8 plus equal to 21 and 21 plus 13 equal to 34. So here you can see the next element is the sum of the previous two elements. So also we can achieve this the example. Here we need to write a program to print the Fibonacci series. So let us see here our main function. First we need to include a standard library stdio.h, and after that you have declared integer main, that is main function will be execute, and integer n. Here we define n equal to 10. Here we know how many numbers of elements we want to print, so here we define n equal to 10 and printf Fibonacci series forward n and %d 01. First already we have print like 0 and 1 according to first 0 and 1. Then next we need to achieve like this one through the recursive function. Here we can see print fifth series n minus 2 because n minus 2 because two numbers are already printed. So when we print fifth series, that is a function. So here you can see we defining why there is no return type of this function print fifth series integer n, passing the integer data type. And here we can see static integer n1. First we define n1 equal to 0, n2 equal to 1 second element, and n3 equal to nothing. Now let us understand what is static variable. Here we define static integer and there is three variables. So static variable have the property of preserving their values even after they are out of their scope. Hence a static variable preserves its previous value in its previous scope and is not initialized again in the new scope. Static variables can be defined inside or outside the function. They are local to the blocks. The default value of static variable is 0. The static variables are alive till the execution of the programs. Here we define a function printfseries will print the Fibonacci series. So here we define static integer n 1 0 into 1 and 3, and after that we have a check like if n greater than 0, then what we need to do here means third element 0 1 already you have printed, third element like 1 n1 plus n2. According to the definitions, the next element is the sum of the previous two elements. So here we are adding first element plus second element and defining variable n1 plus n2 equal to n3. Also need to swap value of n2 to n1 and n3 value of n3 to n2. And then after that we printf %d format is fire and n3 according to what value we receive here n3 n1 plus n2 means third element will be printed here. Then again you can see print fifth series n minus 1. Again this function will calling function and again this function will be executed. Now let us understand with the example how this recursive function will print Fibonacci series. Now let us understand the Fibonacci series to print. Here you can see the main function integer n equal to 10, number of element to be printed, and printf. Here you can see Fibonacci series %d %d 0 1. So here you are printing first two element 0 and 1. 0 and 1. So you can see first element 0, second element 1. Now I want to print third element. So here you can see print fifth series n minus 2. Means here we have defined n equal to 10. Then this function print fifth series 10 minus 2 means 8. And this function calling function, then it will call these functions. So you can see this function will call this function, and here you can see 10 minus 2 means 8. Here we passing integer 8 means n becomes 8. Functions here you can see 8, and here you define 8 greater than 0, that is true. Then what value of n3 n1 plus n2. So already we assigned the value n1 equal 0 and n2 equal to 1. So n3 becomes n1 plus n2 means 0 plus 1 equal to 1. So first we write here n3. n3 value now 1. And here you can see we are assigning the value of n2 to n1 and value of n3 to n2. Now let us see what value becomes n1 now and n2 now. n1 equal to n2. So here you can see n2 value 1. So here we can put n1 equal to 1. And what value of n2? n2 value n3. Here you know n3 value means 1. So we can put here n2 value assigning value of n3 means 0 plus 1 means 1. Then what will happen? Here printf, there is a printf function with print on console %d and n3. And n3 what here? n3 we know n3 equal to 1. So 1 will be printed now, that is third element. And after that this is a function again print fifth series and n value what we will get f8. Now this function passing 8 minus 1 means f7 now. Then this function will call again this function, that is called recursive function. So now we can see here, now it will pass f7 now, and here print series and integer n means f7. Now 7 greater than 0, that is true. Then what value of n3? n3 value means n1 plus n2. So here we write n3 and n3 equal to n1 plus n2. Now here first time we define n1 equal to 0, n2 equal to 1, but now it becomes, you can see this statement now, n1 becomes 1, n2 becomes 1, so 1 plus 1 means 2, and after this statement there is another statement n1 equal to n2. Now we are assigning value of n2 to n1, and then in third statement value of assigning n3 to n2. Now let us see now what value of n1. Put here n1. Now here you can see n1 equal to 1, so put here you can see n1 equal to n2. So what value of n2? Here n2 equal to 1, so put 1. Now here again in next statement you can see n2 equal to n3. You are swapping the value. Now put now n2, and what value of n3? What value of n3? So n3 you can see here n3 value 2. Now comes these points. Now other statement printf percent %d n3. So n3, what value of n3? n1 plus n2. So you can see here n3 value 2. Now 2 will be printed here. And after this statement you can see printfibseries means what value of n? That that was 7. 7 minus 1 means 6. Now again this is a function, and this function call again this function. Same function. So what will happen now? F6, calling up this function printf series. Now F6. So this function value of n will be x. Value of n will be 6, and here 6 greater than 0, that is true. Now here you can see n3 equal to n1 plus n2. So you can write here now what value of n3? N1 plus n2. N1 you can see 1, and n2 value 2. 1 plus 2 equal to 3. So in this case n3 value 3. Now again there is another statement n1 equal to n2, n2 equal to n3. Now we are swapping the value. Now n1, what will be n1? n1 value 1. Here you can see 1. No, sorry, n1 equal to n2. Now we have to put n2 value. You can see n2 value 2 here, and n2 equal to n3. So here we put n2 equal to n3. What value of n3? You can see 3. Now there is next statement printf percent %d n3. So n3 means what? We will get n1 plus n2 means this value 3. So now 3 will be printed here, means 2 plus 1 equal to 3. And another statement you can see printf series n minus 1s. N value that is your 6. Now 6 minus 1, that will becomes f5. So now let us see this function's parameter value will be 5, and it will calling this function again to these functions. Now let us see. Here you know n becomes 5, and 5 greater than 0, that is true. Then here n3 statement will be sum of two numbers n1 plus n3. So here you can write n3, and you can see what is value of n3, n1 plus n2. n1 plus n2. n1 plus n2 means 5. 2 plus 3 equal to 5. And then what value of n1? n1 की value n2. So here n2 value is 3. So you can put 3. And what value of n2? n2 equal to n3. So we'll put here n3 value. You can see n3 value is 3. Here you can see n2 equal to n3. So we need to put here n3 value. As you know, n3 value is 5. So n2 equal to 5. Now move to and n3 means 5 value printed here. You can see, and after that you can see printf series n value 5, 5 minus 1, that is f4. Now 4 greater than 0, that's true. Then go to n3. n3 equal to n1 plus n2. So here we write n3, n1 plus n2 means 5 plus 3 equal to 8. Now n3 value will be 8. Now goes n1. n1 value n1 equal to n2. Here you can see n2 equal to 5. So you can write here n2 value 5. And what value of n2? So here n2 equal to n3 you have written here. So you can see n3 equal to 8 now. Now after that you can see printf another statement n3. Here you can see n3 value 8. So 8 will be printed here after 5. That is sum of previous two elements 3 plus 5 equal to 8. And here you can see n value was 4. So this function printf series 4 minus 1, that's become 3. Now this function will be like f3 now. And again this is a function, so it will call this function again. So when we will go here 3 greater than 0, n becomes 3, and 3 greater than 0, that is true. Now we know the here n3 value of n3. n1 plus n2. So here you can see n1 plus 8, n2, 8 plus 5 means 13. And assigning value of n2 to n1 and value of n3 to n2. Let us see. Now n1 equal to n2. So here you can see n2 value 8 and n2 equal to n3. Now put here n2 and n3 value 13. So you can put 13. Now at the another statement printf n3. So here you can see n3 value 13. So 13 will be printed now. Now after that you can see printf series. Now here we are getting 3, n value is 3. So 3 minus 1, that is 2. Again this is a function. So you can write here functions 2. Now put here n3, n1 plus n2. Here you can see n1 plus n2. 18, 8 plus 13 means 21. And value of n1 and value of n2. Here you can see value of n1 equal to n2. n2 you can see 13. And n2 equal to n3. Here you can see n3 equal to 30. Here n2 equal to n3. Now n3 becomes 21. So you can now write n2 equal to 21. And here there is statement printf %d n3. Here you can see N3. What value of N3? That is 21. Now 21 will be printed. And after this, there is a function printfibseries n minus 1. Here we know n value is 2, so 2 minus 1, that is 1. So again, this is a function like f of 1. Now f1 greater than 0, that is true. So then we write here n3. N3 value n1 plus n2. So you can write 13 plus 21 means 3 on 4, 34. And n1, n2. Here you can see n1 equal to n2. Now we write here n2 value. What is n2 value? That is 21. So you put here 21. And what is n2 value means n3. Here you can see n3 becomes 34. So you can write 34. Now printf %d n3. Now n3 becomes 34. So 34 will be printed now. Then after that there is a function print fit which reach now n minus 1. N value becomes 1, 1 minus 1, that is 0. Again this is a functions. So you can write here f0. Now n becomes 0 and you can see n greater than 0. When 0 greater than 0, that is false. Then that is statement will not execute further. So here you can see statement will be executed successfully, and you can see the Fibonacci series will be printed here. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Thanks for watching my YouTube videos. If you want to more videos, please subscribe my YouTube channel.